Now, as I promised, or maybe threatened, I've got a symmetry argument to show, hopefully, that this integral should be 0. I'm pretty sure this works out, but let's go through it in detail so I don't miss anything. And if I do miss something, hopefully you'll pick it up. Okay. Comparing the first quadrant to the second, or to the fourth quadrant, how do our values of e to the x sine of xy compare? Well, for a point in the first quadrant and its reflection through the x-axis down here in the fourth quadrant, e to the x doesn't change. Okay, e to the x is the same here as it is here. Now what about the sine of xy? Well, the absolute value of xy is the same, this point and this point. If this is a reflection, that means that the x value here is the negative of the x value here. So the the y value here is the negative of the y value here. So the absolute value of the y value is the same at both points. The x value is the same. But xy reverses sign between this point and this point. Specifically, xy is positive here because both x and y are positive. Down here, x is positive but y is negative. And the sine function is an odd function. The sine of a negative value is the same as, is equal and opposite to the sine of the absolute value of that negative value. So the sine function is odd, which means that the value here is equal and opposite to the value here. So that when you evaluate this over at least the right half of the circle, all the values you get here are equal and opposite to the values you get here, and they apply to the same area down here as they do up here. So the integral is 0, at least over this half. Well, the same argument can be made over here. Okay, in this quadrant, the xy is negative. In this quadrant, it's positive, but you make the same symmetry argument between top and bottom. For the same x value, the value of e to the x sine y will be the negative up here because the xy is negative. It'll be positive down here, and the two values will be equal and opposite, and everything will cancel out. So the integral is 0, and that's a symmetry argument. By the symmetry of the circle and the antisymmetry of the sine function relative to the x-axis, we conclude that this integral is 0 without ever having to do any integration by parts or anything. Doesn't mean it's not a good exercise to do the integration by parts. You should do that. That's Calculus 1 technique. If you have to review it, review it. We really need in this course, with the limited time we have, to concentrate not on integration technique, but on the application of Green's theorem and so forth, the setting up of the integrals. Doesn't mean that you don't have to do the integration, just means that I'm not going to talk about it a whole lot here, but I do have other videos that you have reference to where I do all those details. So there's your symmetry argument. You could think about a similar symmetry argument for whatever you've got left here after you do all the simplification you can. Sine t, cosine t is a lot like xy. You could actually translate this back to an extent into xy's and then see what simplifies and what kind of symmetry arguments you can make. You can make the same symmetry arguments in terms of the sines and cosines of t. Sine of t is an odd function, cosine of t is an even function, etc.